just some ones that you might see. I picked 3 of these just because they look kind of unique. So here's the first one. I have 5x squared y minus 3xy, and I'm going to add it to 2x squared y minus xy. Now, can these be added together? Can these be added together? Yes, because you have a 5x squared y and a 5x squared y. Those are combined together. And then you have a xy and an xy. So you can combine like terms. So if I were to write these with the terms next to each other, that would be 5x squared y plus 2x squared y. And then plus minus 3xy plus a minus xy. Why can I do that? Because these are like terms: x squared y, an xy, and an xy. The constants don't matter when you're combining like terms. It's the terms that matter, okay? So those do work. So when I add those together, I get what? The 5 plus the 2, that's going to be 7x squared y. And then a minus 3 and a minus 1, that's a minus 4. See that? 7x squared y and a minus 4x squared. Do you remember what I said about the degree? It's of the largest term. These are understood ones here. This has a degree, this by itself has a degree of 2. This has a degree of 3, which is the largest term. So the entire binomial, because there's 2 terms, has a degree of 3. Cool beans? Cool. Let's look at another one. And again, I picked ones that were kind of oddballs, okay? Kind of oddballs. Woo. This is getting good. This is getting really good. Okay. This one is 7x plus 5y squared. 7x plus 5y squared. You can do the FOIL method. Now, I did this one because it's very tempting for people to say, oh, this is 7x squared plus 5y squared. But that's not right. You cannot distribute this inside. The only things that you can distribute is when there's a minus on the outside, you can distribute that way. Or if there's a number on the outside, then yes, you can distribute. But when you have exponents, exponents tells you how many times that whatever's in the parentheses exists. So this is really 7x plus 5y times 7x plus 5y. Y'all see that? 7x plus 5y times 7x plus 5y. 7x plus 5y times 7x plus 5y. So, and then another thing people say, oh, is this the sum and difference of 2 terms? No, because these are both sums. In order for it to be the sum and difference of 2 terms, this would have to be minus, and it's not. And then you say, oh, well, are we squaring? Are we squaring a binomial? Well, sort of, but whatever your, what do you call it? What am I trying to say? Yes, but if you don't remember that it's a squaring a binomial, you can do the FOIL method. That's what I was trying to say. You can do the FOIL method, but this is the squaring of a binomial. Let me write that for you. Remember, if it was a plus b squared, then they said you take a squared plus 2ab plus b squared. But I'm going to be honest with you, sometimes when you see this, you don't automatically see that you're squaring a binomial. So the default is the FOIL method. And the default to the default is the distributive property. 7x times the 5y, and then 5y and then add everything together, okay? 1/2 dozen the other. Just pick one that you're very comfortable with until you memorize these properties. Just do the math, okay? Do the FOIL is what I'm saying, or do the distributive property. So let's come down here. I'm going to follow the property. So my A is 7x. My B is 5y. Y'all see that? And that's what I'm saying. It kind of saves you some math. So 7x times 7x is going to be 49x squared. 7 times 2 is going to be 14x. And then if you're going to say 14 times the 5, putting that in my calculator, that is 70. 70xy, because you still have the variable, see? And then 5y squared, 25y squared. 25y squared. This is a trinomial of degree 2. Trinomial of degree 2. If you look, that's a 1, that's a 1, and this has a square. So it's of a degree 2. Cool beans? Whew. All right. Do I have room here? I do. Now y'all check this one out. You might not see these too often. They try to sneak them in on you, but I think y'all might get a kick out of this one. Let's see. Y'all are probably like, we don't get a kick out of none of this math, Dr. B. So quit playing, right? Okay. 3x plus 4y squared minus 3x minus 4y squared. All right, y'all. What are we working with here? What are we working with here? Now, remember, you cannot distribute an exponent. That's not how the exponents work. You cannot distribute an exponent. That's not how exponents work. Well, you said, Dr. B, we could distribute the minus. Well, you only can distribute the minus when you've already taken care of what's in the parentheses. So when you follow order of operations, it's parentheses, exponents, multiplication, division, addition, and subtraction, right? Well, you can't distribute this yet because this needs to be squared. So you have to take care of the square first. Now, let's say you don't know any of the properties. If you don't know any of the properties and you know this means duplicate, this is what I would do. And I would put this in a massive bracket just so I show my two pieces. Okay, I put it in brackets because I want to show that this has two parts and they're subtracted. All right, now what do you see? There's properties, but I just want you to see, you can FOIL this, right? You can do the distributive property. You can FOIL this and do the distributive property. And then after you do that, you can distribute the minus to everything. If y'all want, let me go ahead and do that. And then I'm going to show you the properties. I'll do it the long way and then I'll show you the shortcut because this is the last example that I have. So let's do the distributive property. Okay, so I'm going to take 3x times 3x, 3x times 4y, 4y. You know what? I'm going to do the FOIL because I'm hoping by this point you remember FOIL. So let me just put FOIL up here. And then I'm going to show y'all the property. Because then you're going to be like, oh, bet. If you know the properties, hopefully whoever your professor is, they let you have a formula sheet. Okay, first, that's going to be 3x times 3x, right? And these are going to be the same color in this one bracket, okay? And then the outside, 3x times 4y. The inside, this is going to be long. Okay. 4y, the inside. and then the last, which is going to be 4y, 4y. Okay, I'm going to do top and bottom just because I'm running out of room. So this is minus. That's the minus sign. And then now let's do this right-hand side. So the first, the outside, minus 4y. The inside, minus 4y. And then the last, minus 4y, minus 4y. So far, so good? Okay, let's move this to the next page. Okay. Then y'all are going to see, oh, the properties are so much better. Yeah. Okay, so let's do this first one here. So that gives you 3 times 3, that's 9x squared. 3 times 4, that's 12xy. 4 times 3, 12xy. And 4 times 4, 16y squared. Do y'all see that? 9x squared, 12xy, 12xy, 16y squared. And we're still subtracting. We're still subtracting, okay? Don't forget, we're still subtracting. So now we have 9x squared minus 12xy, or I'm going to say plus a negative 12xy, plus a negative 12xy, plus a positive 16y squared. 4 times negative 3 is going to be the 12. So that's where we're getting the negatives. Okay. Cool beans. So let's keep going. So the top now, and I'm doing this the long way because I want to show you why the properties really help. So then the top one, we have 9x squared, 12x, that's going to 12 plus 12 is 24, xy plus 16y squared, right? Minus 9x squared minus 24xy, because a minus 12 and a minus 12. And then you're going to have plus 16y squared. Okay, now we're going to distribute this minus sign to everybody. Okay, so then we have 9x squared plus 24xy plus 16y squared minus, matter of fact, I'll go ahead and put minus 9x squared plus 24xy minus 16y squared. We took the minus to everybody. So this was positive, it became negative. This was negative, it became positive. This was positive, it became negative. Now we can combine like terms. 9x squared plus a negative 9x squared, because I can say plus a minus. 9x squared plus a negative 9x squared, that's 0, right? If it helps for me to write them side by side, I will. 9x squared plus a negative 9x squared plus 24xy plus a 24xy plus a 16y squared minus a 16y squared, or plus a negative 16y squared, however you want to write it. All right. 9x squared plus 9x squared, that's 0, right? 24xy plus 24xy, that's a 48. These were all equals. and then a 16y squared and a plus a minus 16y squared, that's 0 too, right? So this is our answer. This is a monomial of degree 2. Why? Because these are understood ones, right? You're like, my goodness, we did all of that just to get to that? Let me show you something. Let me show you something. Let me show you something. What properties do you see? Do you see any properties? Yes. Say, yes, I do. Say, yes, I see some properties. Let me show you. This is a plus b squared, right? And this is a minus b squared. Y'all see that? And they're subtracted. So do you remember our properties? Let me get those. Okay. These are our properties. These are our properties. So let's follow what it says. Okay, with the green, that means 3x squared plus 2 times 3x times 4y plus 4y squared minus 3x squared minus 2 times 3x times 4y plus 4y squared. Now I'm going to distribute, well, let's simplify and then we'll distribute. Okay, so then that's 9x squared plus 6 times 4, 24y plus 4y squared minus 9x squared minus 24y, 16y squared. I paused because y'all know that ain't right. Ain't nobody, y'all didn't say nothing. That wasn't right. Now it's right. You gotta square the number and the term, right? Okay. So now we're gonna distribute the minus sign to everybody. Okay. So we have 9x squared plus 24y plus 16y squared plus a minus 9x squared plus a 24y minus a negative 16y squared. And you say, why is the 24 positive? Because we did minus to minus. Okay, so that became minus, that became positive, and then that became minus. All right, now we can combine like terms. I will put the like terms together. So we have 9x squared plus a negative 9x squared. If y'all haven't learned by now, I like to show all of the steps, because if you know the steps, then this doesn't hurt you. But if you don't know the steps, I don't want to leave you behind. So that's why I write out all the steps. So those of you that get tired of that, too bad. We want to bring everybody along, okay? So now that's gone, right? Was that 48? But what did we do wrong? Y'all see what we did wrong? I'm going to keep going and then y'all tell me what we did wrong. And then this right here. I always see it after. I think this has been a long lesson, so I'm getting tired. Those cancel out too, right? What did we do wrong here? What did we do wrong here? You see, it's very easy to leave off terms. Very easy. What did we do wrong here? XY. Y'all see it? XY, 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 XY. It's very easy. Very, very easy to leave off terms, especially when you're tired, right? Okay, so let me fix that. XY, 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 XY. XY. This is the last problem, right? Thank goodness. Okay, say we getting tired, boss. All right, so this is all we have left. So that's going to be a 48 XY. So that's where I'm talking about the properties save you, because if you notice, this was our work here by using the two properties, but this was our work when we didn't use the two properties. We started here. Okay, we foiled that, we got this whole thing minus this whole thing. Then we wrote out all the terms that we needed so we could see all the steps. Same thing here, we combined like terms here. Then we were able to distribute the minus and put it together. But when we used the properties, it took us straight to this part here, which saved us a lot of time. Remember, if you don't remember the properties, distributive property will work, the FOIL will work, you'll just do more math. But if you can learn the properties, or you have a professor that allows you to have a sheet of all of these properties, it will make your math so much lighter.